The question that I have is, could you describe the method of section? Just to remind ourselves, the goals of an analysis of a truss are to determine the values of support reaction and the member forces. There are two methods that are available to us, the method of joints and the method of section. This video is on the method of section. The method of section is ideal when forces are needed on a few members of the truss. Supposing, say, you've already analyzed this truss using a computer software, but you want to have an independent way to check your results. Typically, you would find values for some of the unknowns and compare the results with those that you got through your computer analysis. The method of section is an ideal method for that purpose. You calculate the forces on a few members of the truss manually by hand by this method, and then compare the results with your computer analysis. Referring to this example, supposing, say, we are interested in finding the forces on members HG, HC, and PC. So this is what you do. You divide the truss into two parts by sectioning like this. You then select one of the two parts for analysis, complete the free body diagram for that part, and use a suitable combination of these equilibrium equations applied for that part in order to find the unknown forces. So there's a lot of similarities between this and what we did in finding the internal forces on a beam. Remember how we did that, right? We sectioned the beam at the point where we are interested in calculating the internal forces at, separate the beam into left and the right parts. We use one of the two parts in order to find the internal forces, right? So this is pretty similar to that. So let's look at some specific guidelines here. When you section the truss, you want to do that in such a way that you do not cut through more than 3 members of the truss. The forces on the members that you cut through become the unknowns of the problem, and if there are more than 3 unknowns, you can't solve because there are only 3 equilibrium equations available to you, right? Also, it goes without saying that you want to cut through the members that you are interested in calculating the forces on. Otherwise, you'll be just wasting your time, right? For example, referring to this truss, if you are interested in finding the forces on HG, HC, and BC, this is the most optimal way to section the truss. When you do, you're cutting through this member, and this member, a total of 3 members, and therefore you are following the guidelines. Number 2, you're cutting through the members that you are interested in calculating the forces at, right? You're cutting and separating the truss into 2 parts. This is your first part, and this is your second part, part 1 and part 2. So you can use either one of those in principle to find the forces on these members. But which part do we select? Well, fundamentally, you could select any part, but from a practical point of view, you want to select the part that is easier to analyze. For example, in this case, the left side might be a little easier than the right side to analyze because there are more forces on the right side than on the left side. Well, you might say, well, there are 2 reactions on the left side. There's only 1 reaction on the right side, right? But in this example, you can see that the horizontal component of the reaction at point A is trivially 0 because there are no external forces acting in the horizontal direction, therefore AX is 0. Your next step is to complete the free body diagram for the part that you have selected for further analysis. If there are support reactions on the side that you have selected, you want to find them first. For example, if I select part 1 for analysis, I need to find the support reactions, AX and AY, first. And of course, you do that by considering the equilibrium of the whole structure. Also, as part of completing the free body diagram for part 1, you want to mark and label these internal forces. Alright, so you also want to indicate arrows for those forces. Remember, the forces can either be tensions or compression, but I recommend that you assume them to be tensions, and your final answers will tell you whether your assumptions are right or wrong. Finally, once you have completed the free body diagram for the part that you want to analyze, you use a suitable combination of these equilibrium equations to solve for the unknown forces. Couple of notes about the moment equilibrium equation. You don't necessarily have to use just one moment equilibrium equation. You could use two moment equilibrium equations. Only restriction is that you cannot use more than three equilibrium equations in total. So if you use two of these moment equations, then of course your force equation will have to be just one of them, right? The second note is that the moment equilibrium equations can be written about any point, even a point that actually lies on part 2, even though part 1 is your free body diagram, right? But the point can be anywhere in space here. For example, writing the moment equilibrium equation about point C, right, for the free body diagram in part 1 would exclude these two forces, right? Because these two forces are passing through point C. So that moment equilibrium equation will have only one unknown, which is FHG, and therefore you can go ahead and find FHG right away. For that purpose, you need to have the relevant geometrical details in your free body diagram, right? So one way to do that is to section and draw like I have done here. So I'm keeping both part 1 and part 2 right there in my picture. But if you're going to draw the free body diagram for part 1 separately somewhere here, then you better keep the geometrical details of point C and maybe point G or whatever, right? All right, this is what is known as the method of section.